Hey guys, I'm Pat Kelly. Okay, in this problem, they give us another differential equation. They ask us to solve this using the method of undetermined coefficients. All right, you'll see that in play here when we do our work. And what it really comes down to is when you have something on the other side of the equal sign other than 0. Okay, and that's what we usually call capital F of x. So we'll address that in a minute. But in fact, the first way to start this type of problem is to almost ignore that there is something there. And what you're doing is you're trying to find a solution to the homogeneous version of this equation. So imagine that there actually was a 0 there. So what we'd be looking at is y double prime plus 7y prime plus 12y equals 0. But please realize, if you're looking at your work later on, is that you're not magically making that other side of the equation disappear. You're addressing the homogeneous version of this equation. And what we do is we find an answer for the homogeneous, then we'll find an answer for the particular and put them together. And if I'm talking too quickly, you'll see that done in the end of this problem. So to solve this homogeneous version of the differential equation, you go to your hopefully familiar and comfortable characteristic equation work. So I'd be looking at m squared plus 7m plus 12 equals 0. This one actually does factor nicely. M plus 3, m plus 4 equals 0. And so we get m values of minus 3 or minus 4. Okay? Everything's behaving. Now what you do with your answers to the characteristic equation, since these are real solutions to that equation, that means my y will equal some unknown constants, coefficients in front, and then e raised to that minus 3 as a coefficient of x in the exponent of e, plus c2 e raised to the minus 4x. Okay, look good? Now I'm going to add one little tagline here, if you will, is that I think this work looks good, but that's the y, that's the answer, that's the solution to your homogeneous version. So let's put a subscript of h on that, okay? Because then what we're going to do, let me slide over and do some different work. What we're going to do is find the solution to our particular, the particular solution to our differential equation. Okay, sometimes a mouthful. But then what I do in order to find that particular solution, I told you, a mouthful, is I focus on that capital F of x. And it could look like anything. Ours is a polynomial. And your y sub p for particular will end up equaling your most generic attempt, your most generic representation of that capital F of x. So since mine's a polynomial of degree 1, right, x is to the 1 power, my most generic representation of that is going to be some constant that I don't know what it is, capital A. I'm going to put a subscript of 0 on it, only so that I can use another capital A with a subscript of 1 as the coefficient of x to the 1 power. All right, in a different problem, if your polynomial goes up to, let's say, the 3rd power, you're going to have a0, a1, a2, and even a3, and then the x powers, constant, 1 power, 2 power, 3 power. Okay? Make sure that your particular solution is the most generic version of the capital F. Polynomial, make sure it's to the same degree. Okay, let's move on. Then what I'm going to do is I'm going to take this y sub p and I'm going to differentiate it once, y sub p prime. And it differentiates very nicely, right, because it is a polynomial. That's just going to be a sub 1. And why I'm doing this is because I'm going to use that expression to plug in the original problem where there's a y prime. And I'm pointing that out to you then because if you're not sure where to go next, notice in your original problem you also have a y double prime, which means back to this work, let's differentiate again to get a y sub p double prime. Okay? And that's even easier to differentiate because the y prime was a constant, your a's are constants, so your derivative is 0. Okay, good. Now what I do with that information is I go back to the original, but I'm going to put a sub p everywhere. So y double prime sub p plus 7y sub p single prime plus 12y sub p. And we know from the given problem, the given equation, that that has to equal 3x plus 1. Right? So, substituting in, my y double prime sub p is 0, so that's good. 7 times y sub p prime, so 7 times just this a sub 1, 7 a sub 1, plus 12 times y sub p, which is up here. I'll put parentheses, 12 multiplies by all of that. And then the magic of this is something we've seen before, that must equal that 3x plus 1. Okay? I say magic then because this will give us our values for A0 and A1 when we do a balancing act, which we'll do right now. The balancing act, let me start with the x's. The x term on the right has a coefficient of 3. There's 3 x's on the right-hand side. On the left-hand side, do a little bit of algebra in my head, all I have is 12 multiplying by this a1 for the x term. So you have 12a1 equaling, it must equal that 3. Balancing the x terms on either side of the equation. And so a1, real simple arithmetic here, divide over the 12, and we get a 4th. Okay, now let's find a sub 0 by balancing the constants. On the left-hand side, I'm going to go ahead and put in my 1/4 as I go. So 7 times that 1/4 is 7/4. Excuse me. Okay, and then plus 12a0 is 12a sub 0. And that would be it for the constant terms on my left-hand side, and that must balance with the constant term on the right-hand side, which is just 1. So 12a sub 0 equals, let's do some arithmetic again. This is like 4 over 4, subtracting 7 over 4, so minus 3/4. And then my a sub 0 equals, divide over the 12, and I think I should be looking at a minus 1/16, okay? All right, what that tells me then, my a1, my a0, let's put those into our y sub p, the particular solution. I'll go down here. Y sub p equals a0 of minus 1/16 plus the a1 of 1/4 times x. Okay, good. Almost done. We're going to put the two pieces of the puzzle together. Something I was rambling about at the beginning of the problem is that you take your homogeneous solution, you take your particular solution, and your final solution is just the sum of those two. Okay, so let me go over here. Final answer, y without any subscript equals y from your homogeneous plus y from your particular. I'll slip down just so I know I have enough room. Y homogeneous is c sub 1 e raised to the minus 3x plus c sub 2 e raised to the minus 4x, and then minus 1/16 plus 1/4 x. All right, you done did good. So do some more on your own, you'll get the hang of it.